In this lecture, we will derive an integral formula for the volume of a solid using parallel plane sections. When using the method of parallel plane sections to find the volume of a solid such as the one shown on screen, we slice up the solid using planes that are parallel to one another. For a good approximation of the volume, we use a large number of slices, so that the thickness of the thickest of all the slices is quite small. For the viewer to see the slices better, we remove the slicing planes from the image and some of the slices. We turn our attention to one of the slices. Suppose this is the Ith slice. Take the front face of this slice. We shade this front face green. We take this face to be the representative cross-section of the slice. If the thickness of the slice is quite small, then the volume of the slice is approximately equal to the cross-sectional area times the thickness of the slice. By the way, we are measuring the thickness of the slice in the direction perpendicular to the cross-section. In this case, this direction is parallel to the x-axis. Since the thickness is parallel to the x-axis, we designate the thickness of the slice to be delta sub I x. Since the thickness of the slice is in terms of x, we must express the cross-sectional area of the slice in terms of x as well. Suppose that the cross-section we are using is at x equals x sub I. Then we write the cross-sectional area as A of x sub I. And so the approximate volume of the ith slice is A of x sub I times delta sub I x. Now the entire solid is made up of many slices. Suppose that we have a total of n slices making up the entire solid. So we add up all the approximate volumes of the n slices. Then the volume of the solid is approximately equal to the sum from I equals 1 to n of the cross-sectional area A of x sub I of the ith slice times the thickness delta sub I x. Now this summation might be familiar. It is what we call a Riemann sum. Let us suppose that the solid goes from x equals a to x equals b. If the area function a of x is continuous on the closed interval from x equals a to x equals b, the Riemann sum approximation for the volume of the solid should tend to the integral from a to b of a of x, as the maximum thickness of all the slices tends to 0. Therefore, the volume of the solid is equal to the integral from a to b of a of x.